Okay, as I've already said that this diagram forms the basis of your mid-latitude cyclone. So, when we are going to have a look at our mid-latitude cyclone, we are going to have a look firstly at cold and warm fronts. We are going to look at the stages, and we are going to look at the weather, the different weather changes that occur at the mid-latitude cyclone. So let's just have a look at our mid-latitude cyclones. Firstly, people, it's very, very important that you should know the concepts regarding the mid-latitude cyclones. Now, there are two very, very important concepts. The first one has to do with a warm front, and the second one has to do with a cold front. People, if you don't understand how these fronts work, you will never ever understand how the mid-latitude cyclone works. So I will suggest you spend some time, study the warm front, study the cold front, try to figure out how these things work. So let's just have a look at the warm fronts, your two different fronts that we've got here. Firstly, people, the warm front. Now, what's very important with your warm front is that you must know that the air behind the warm front is warm, and the air in front of the warm front is cold. So that is very, very important when you have a look at this. And please remember, people, that the map symbol for your warm front will be this, as I am indicating now here. Now what happens is that your warm air rises over your cold air. You can get the development of clouds and of course rain as well. Now, people, the following one will be our cold front. Now let's have a look at our cold front. Remember, our cold front, the air behind the cold front would be cold. It's very easy to remember. Remember that the front gets its name by looking at the air behind the front. At the warm front, the air behind the front will be warm. Here in this case, at the cold front, the advancing air or the air behind the front will be cold. And of course, the air in front of that front would be warm. Now what happens now? Oh yes, and please check on the symbol also that we use to indicate the cold front on the map. Now what happens is that we get the cold front moving towards the cold air, moving towards the warm air, goes beneath the warm air, and it lifts up the warm air, and eventually you also get your cloud formation and rain. So people, you must understand your concepts, the warm front and the cold front, when it comes to the mid-latitude cyclone. Now, it's very important that we must know the stages of the mid-latitude cyclone. So let's just have a look at the development of the mid-latitude cyclone. Firstly, we've got the initial stage. I'm just going to put on all the stages for you. Then we've got the development stage. Then we've got the mature stage. And then we've got the occlusion. Now these four are the four main stages of your mid-latitude cyclone. And you must be able to identify these stages on a synoptic weather map or on a diagram in the exams. Now, if you have a look at the initial stage, you will see that here we have, in the initial stage, no fronts have developed yet. But in the development stage, we have the possibility of fronts developing, because here we've got warm air moving towards cold air. In other words, in this region here, our cold front can develop here. Have a look at your arrows here. Here you'll see cold air moving towards warm air. In other words, a cold front will be developing here, and a warm front will be developing on that side. Let's just have a look at that. It's very important. Here we've got warm air moving towards cold air. In other words, here we'll have our warm front developing here. Here we've got cold air moving towards warm air, and our cold front will be developing here. A few hours later, you will have the mature stage of the mid-latitude cyclone. And now for the first time, you really can identify your cold front and your warm front. Here we've got our warm air on this side, here we've got the cold air at the bottom. In other words, we will have the warm front on that side, and we will have the cold front on this side. The final stage that we've got would be the occlusion. When we have that the cold front moves towards the warm front, and eventually this warm air, this cold front moving towards the warm front, and this warm section getting narrower and narrower and narrower until these both fronts are occluded. And that is what we call the occlusion stage. Now it's very easy to identify your stages. If you have a look at the warm section of the stage, you will always see that the more developed the cyclone, the smaller or the narrower your warm section of your cyclone will become. So let's just have a look at a typical exam question. Usually, they will give you 1 or 2 or 3 fronts, cyclones, and will ask you which one is older and why. So let's have a look at this one. Now, I've got the 4 stages around this map here, so it's quite easy. So let's see if we can identify it. Of course, that one would be our development stage. We can see that the fronts have just been started to form. This one would be our mature stage. And then, of course, that one, the occlusion stage. You can see here, if you have a look at this small part of the cyclone here, you would see that both the warm front and the cold front is indicated in this part of the cyclone. So this means that here we've got our occlusion, and that would be the older of the 3 cyclones. And people, what you must remember is when you've got a group of cyclones in different stages, we call them a family of cyclones. This has been asked 2 or 3 years ago. What do we call a group of cyclones like that? So people, this would be our development of the mid-latitude cyclone. Now, if we have a look at the mid-latitude cyclone, people, it's very important that we must know the characteristics of this mid-latitude cyclone. So let's just have a look at that. The first thing that you must know, isobar, right? The isobar that we've got on your mid-latitude cyclone. The following thing that you must know is your cold front. So have a look at your cold front. Take note of the symbol that we've got represents the cold front. Have a look at the warm front here. Here we've got the warm front, and again, people, just check the symbol that we use for both these fronts. You may not make these type of mistakes in the exams. Then, of course, we've got a low pressure system that has been formed here. Why have we got a low pressure system? Because we've got rising air at both the warm front and your cold fronts. Then please note your wind rotation. Your wind rotation is always clockwise. Any low pressure in the southern hemisphere, we will have your wind rotation in a clockwise direction. And then we've got the warm sector there, and we've got the cold sector here. Now, we've got a question coming through here. What's the difference between warm and cold fronts? And I would just like you to refer you to this diagram that we've got here. Here we've got the cold front running down here. Here we've got the warm front up here. Now remember, in my introduction, I told you that if you have a look at the cold front, that the air behind the cold front will be cold. If you look at the warm front, the air behind the warm front would be warm. Now let's have a look at this, at our diagram here. Here we've got our cold front. Here we've got the warm sector. Here we've got the cold sector. Please note my arrows. The arrows are moving in that direction. In other words, the air here behind the cold front will be cold, and the air in front of the cold front will be warm. Let's have a look at the warm front. Exactly the same, just the opposite. Here we've got our warm front running down here. The air behind the warm front will be warm, and the air in front of the cold front of the warm front will be cold. So people, you can see the differences between your cold front and your warm front. And please, people, remember the clue, the key that you must remember is I must look at the air behind the front. And as soon as I've established that, then I will be able to see whether it's a warm front or a cold front. Okay, a very, very popular exam question, people, has to do with weather changes during a cold front. What happens when a cold front moves over an area? Now, let's have a look at this synoptic weather map that we've got here. The first thing that I would like to show you is the pressure gradient. Have a look at the isobars. The isobars here are far apart. The isobars here are close to each other. So this, where the isobars are further apart, we call a weak pressure gradient, and this one would be a steep pressure gradient. You must know what's the influence of that on your wind velocity. You'll find your stronger winds, you will find here where the isobars are closer to each other. In other words, where you get your steep gradient, and the winds won't be that strong where you'll find your weak pressure gradient. So let's just have a look now at the weather changes. And people, please remember, this is a very, very important question. On the synoptic weather map, we can see one very, very important change that takes place. If we have a look at that, here we've got our cold front, here we've got the warm front. So have a look at Cape Town here. If we have a look at Cape Town, and we'll see that's a northwesterly wind blowing at Cape Town. In other words, in front of the front, we've got a northwesterly wind. And if we look what's happening behind the front, we see a southwesterly wind. In other words, as a front moves over a place or a region or a town, that means that the wind direction will change from northwest to southwest. That's one of the most important weather changes that take place when a cold front moves over an area. So are there any other changes? Let's just have a look at the weather changes of the cold front. Now what I've got here is a satellite image of exactly the same weather map that you've just seen. There we've got our cold front. There's the warm front as indicated on the previous slide. There's the low pressure. And that's the direction. People, you must know your movement of your direction that you've got here. The movement is, the direction of the movement of the cyclone is that this always moves from west to east, as I've shown you on when we did our introduction. So that is the movement of the cyclone. So let's just have a look at the weather changes that take place here. Now I've put on the weather changes for you here. Now I would like you to have a look at this satellite image. If you look at this part of South Africa, you will see that there's nearly no cloud coverage here. And behind the cold front here we've got lots of cloud coverage. In other words, our weather on this side of the front will not be the same as the weather on that side of the front. So this means I must know what weather changes take place. Let's have a look. Firstly, a northwesterly wind, it changes into a southwesterly wind. High temperature in front of the front, in other words, low temperature behind. In other words, when a cold front moves over an area, the temperature will drop. Now please people, bear the previous slide in mind when I showed you the characteristics of the cyclone. And one of the characteristics was that here in this area, we would usually find our cold air. And that's the reason why the temperature drops. Then if you look at the cloud cover, in front of the cold front, few or no clouds. Look at the high density cloud cover here. Of course, we'll have no precipitation there because there are very few clouds. Look at the clouds on this side. Here we'll have a high pressure, here we've got a low pressure. So people, just to summarize all this, let's have a look at what weather changes take place when a cold front moves over an area. Firstly, the wind changes from northwest to southwest. You must also know why. The reason why the wind changes from northwest to southwest is because of the clockwise rotation around a low pressure system. The second one, the temperature drops. High temperature in front, low temperature behind. Why does the temperature drop? Because the cold air mass always lies behind your cold front. People, you see, you must know why. You mustn't only know the changes. The following one, if you ever look at the satellite image again, few or no clouds here, high cloud cover there. Why have we got this? Because if we get our fronts, then we've got rising air, we've got condensation and clouds will form. And of course, precipitation will take place. So people, this is very important. You must know your weather changes that take place when you have a look at a cold front.